All right, here we have a decibels and sound intensity / energy question, okay? It's how many times more power is released by a sound of 90 dB at 15 meters than one that is 75 decibels at 18 meters, all right? Now remember, decibels isn't like an innate property of the sound, it's a property of a sound at a certain distance. Okay, so we have to specify the distances, otherwise it doesn't mean anything. All right, so we want to figure out power. So we got to go from decibels to intensity first. You can't convert decibels to anything else. So decibels to intensity. So we got 90 dB. Okay? So we know that dB is equal to 10 log intensity over I naught. This is the I naught is going to be a constant. Okay? I naught is 10 to the negative 12. All right, and that's the threshold of hearing. Okay, so we got dB, we go 90 equals 10 log intensity of 90 of the 90 decibel sound versus 10 to the negative 12. Okay, if we solve that, we should get that I90 is 0.001. All right, now let's do the same thing for the other one. Just get it out of the way. So we got again, what else up here? dB equals 10 log I75 over I naught. Okay? 75 equals 10 log I75 over I naught. And before we go any further, how do we get out of this? So we're going to divide by 10, that's our first thing. But how do we solve this equation? How do we cancel a log? All right, to cancel a 10 multiply, we divide by 10. We get 7.5 equals log I75 over I naught. And the answer is we take it to the power of 10. Okay, so we get 10 to the 7.5 equals I75 over 10 to the negative 12. And we end up getting that I75 is equal to 0.000032. Now we got intensity, we got to go to power. Okay, let's do this one right here. The power equation is I90 equals power over 4 pi r squared. Okay, so that means that 0.001 is equal to power over 4 pi times 15 squared. And it should come out that our power is 2.827 okay, watts, because watts are the unit of power. All right, we do the same thing over here. And again, we get I75 equals power over 4 pi r squared equals power over 4 pi times 18 squared. Okay? Going from there, we can solve it. Now, I would like to draw attention to the 4 pi r squared. What does that equate to? It's the surface area of a sphere. So that's really where it comes from. The sound expands radially, so it's spreading out over the surface of a sphere, essentially. Okay, we should get that I75 is 0.13. Now, to get the ratios, how many times more power is released by the louder one than the quieter one? We would get 2.827 over 0.13, and that's going to equal 21.75 times as loud. And that's a decibels problem. Woo!